Hi, in this video, I will be showing you problem number 23 of chapter 11, section 4. Determine whether the series converges or diverges. Sigma n varying from 1 through infinity, 4 plus 2n divided by 3 plus n square, the whole power 4. Anytime where the comparison test is not obvious, the limit comparison test would work. So, anytime you have an addition or subtraction on the numerator with the polynomials, and then numerator is a polynomial, denominator is a polynomial to the power something, then the limit comparison test would work. The limit comparison test, suppose sigma an and sigma bn are series with positive terms. If limit as n approaching infinity of an over bn, n is the nth term of the given series and bn is the nth term of the known series you're comparing with. If limit of the ratio of the nth term of the given over the nth term of the known series is equal to c, where c is a finite number and it's a positive number too, then either both series would converge or both series would diverge. What it means is the sigma bn is the known series that you are comparing with. If sigma bn is something like p series or a geometric series for which you know the convergence. Let's say if sigma bn is convergent, then sigma an would also converge. If sigma bn is divergent, then sigma an would also diverge. For that, we have to establish this ratio, and the limit of this ratio is a finite positive number. So we have to choose a suitable sigma bn for which the convergence or divergence is known or can be determined easily. Because if you look at the given series an, so it is a polynomial whose term is dominated by 2n. Here the denominator is dominated by n squared to the power 4, which is n to the power 8. So we are going to compare the given series with sigma bn. You choose the series as the dominant term over the numerator over the dominant term over the denominator. So if you simplify that, it is 2n divided by n to the power 8, sigma of course. So it is sigma 2 over n to the power 7, which is a p series 2 over n to the power p, where p equal to 7, which is more than 1. So it is a convergent p series. So we have picked a series which is convergent. So if we use the limit comparison test and establish the ratio, because sigma bn is convergent, we can conclude that sigma an also converges. Before doing so, we have to establish this limit, the sigma n varying from infinity, approaching infinity an over bn equal to c. So let's consider an over bn. So an is 4 plus 2n over 3 plus n squared to the power 4. Then bn, we will take it this way. Even though we simplified that to 2 over n to the 7, if we keep it this way, it is easy to divide. So let's keep the bn as 2n over n to the power 8. Now the ratio over ratio, so we are going to flip and multiply. We are going to simplify this. It's 4 plus 2n over any term in the denominator, we will pick 2n. So in fact, I'm going to switch these two, this and this. The product is commutative, so whether you write 3 plus n squared to the power 4 times 2n or 2n times 3 plus n squared to the power 4, it doesn't matter. But here, how we want to divide is more important. So it is n to the power 8 on top. And then I'm going to combine that with 3 plus n squared to the power 4 below. So this will give us 4 over 2n, so divide each term, 2n over 2n, which is 1, times n to the power 8 divided by 3 plus n square to the power 4. In order to simplify this, so this is after all 4 over 2n plus 1. As n approaching infinity, the first term is going to approach 0. This is the one we have to be careful with. It's divide both the numerator and the denominator by the highest exponent of n. So the whole thing in now reduces to 4 over 2n plus 1, then n to the power 8 over n to the power 8, that will be 1. But when you divide 3 plus n squared to the power 4 by n to the power 8, it's not going to be an easy division. It's a binomial to the power 4. So when you expand, it will become 5 terms. So instead of expanding, which will give us a very large expression, so we are going to do a quicker simplification here. 3 plus n square to the power 4. And I'm going to write this n to the power 8 as n square to the power 4. So n squared to the power 4 is n to the power 8. So I am putting that whole thing in the parentheses. So it is 3 plus n squared to the power 4 over n squared to the power 4. N squared to the power 4 is after all n to the power 8. Now you allow limit as n approaching infinity of an over bn, which is limit as n approaching infinity of this whole thing. Notice here this part 4 over 2n part approaches 0, then plus 1. Then it is 1 divided by 3 over n square within the parentheses, which approaches 0, plus n square over n square, which is 1, the whole thing to the power of 4, so which is just 1. So the entire expression becomes just 1 when you allow n to approach infinity. So we have established this in this ratio here, limit as n approaching infinity, an over bn equal to c, where c is here 1, so c equal to 1 also it is positive. So by limit comparison test, LCT, for limit comparison test, sigma an and sigma bn behave alike, converge or diverge together, but we already established that sigma bn converges. So sigma bn converges, sigma an, which is a given series, which is 4 plus 2n over 3 plus n squared to the power of 4, n varying from 1 to infinity, also converges. Keep in mind, whenever you do the testing of convergence, you have to first of all choose an appropriate test. So in this case, we have chosen limit comparison test. Establish whatever the requirement is. So here we have to establish limit as n approaching infinity an over bn equal to c, and c should be a finite positive number. So you have to suitably choose the sigma bn here. Usually it is the higher dominant term over the numerator over dominant term over the denominator. Then see the nature of that known series. It could be a p series, or it could be sometimes a geometric series. So say whether it is convergent or divergent, and then you establish the ratio and then allow n to approach infinity. And if the ratio is a finite positive number, then whatever the behavior of sigma Bn is the same as the behavior of sigma An as well. Hope this video helps.